Hey guys, so in the previous video we discussed the Bresenham circle drawing algorithms algo, that is the algorithm. Now we are going to discuss its derivation. Now this is a very important derivation and it is a little lengthy derivation but it's easy to understand. So keep a close watch on the video as this derivation is generally asked in the exams. So first of all we will create an octant of a circle. That is, we won't be creating the whole circle, we will just be using one of its octants. That is, this is the octant. Now let us consider a point A. That is, this is point A outside of the circle, and this is the point B over here, which is inside the circle. And this circle is of radius r. Now let us again consider a distance. That is, first of all, let me virtually connect this to the origin, and let me also connect this to the origin. Now, now we will write this distance. That is dA. dA will be the distance from this point. That is from point A to the origin. That is till this point. And this point, from this point, that is from point A to the circumference of the circle, will be given as del A. That is, this distance is del A, and this distance from point A to the origin is dA. Now similarly we will do this for B, that is from point B to the origin will be given as the distance dB, and from dB, from point B to the circumference of the circle from inside, will be given as del B. Now you must be noticing that this distance is r, and this distance is also r, as already stated. So these are the 2 points, that is A, and this is the second point, that is B. Now we will be writing the coordinates for these 2 points. That is, A will be given as xk plus 1 and yk, whereas B will be given by xk plus 1 comma yk minus 1. And please be sure that these are not in the subscript, and x1 is being added to xk, and similarly over here 1 is being subtracted from yk, and 1 is being added to xk over here. And now we will write the values of dA. That is, we will write the value of this distance, that is dA, from point A to the origin, that is still here. So we will simply be using the distance formula, that is, we will write xk plus 1 minus 0, that is the origin, that is this point is 0 comma 0. We are simply finding its distance from this point, that is point A, and whole square plus yk minus 0 whole square to the under root. So we have simply found out the distance dA, which will come out to be xk plus 1 whole square plus yk whole square under root. Now similarly we will find out dB, that is the distance from B to the origin. So we will find it out by simply using the distance formula, that is xk plus 1 minus 0. I won't be writing the minus 0 part again, and simply over here you will get yk minus 1 whole square under root. So these are the two distances, that is dA and dB, that we have found out. Now let us write what is dA and del A and del B. That is, del A will be equal to dA minus r. That is, if you carefully look at the diagram, you will see that del A is equal to dA minus r. And similarly, we will write the value of dB, which will come out to be equal to dB minus r. Now, many of you must be thinking that dB should be r minus, it should be r minus dB. That is, del B should be r minus dB. But we have written dB minus r. That makes no difference, but the value of dB will always be negative. Just keep in mind. And the value of dA will always be positive, as the value of del A will always be positive, and value of del B will always be negative. Now let us remove the square roots. That is, to remove the square roots, we will write del A dash as dA square minus r square, and similarly we will write del B dash as dB square minus r square. That is, these are the two values of del A and del B. That is, we have found out del b dash and del a dash and del b dash. Now we will be finding out the decision parameter, which is the most important part. Let me change the color. That is, the decision parameter capital D will be given by del a dash plus del b dash. That is, now we will be writing the formula as dA square minus r square plus dB square minus r square. Now we will be opening the brackets, that is, we will be using the value of dA as this one, that is equation 1, and we will be using the value of dB as this, that is equation 2. So now we will put the values of dA and dB, that is, we will get xk plus 1 whole square plus yk whole square minus r square. Then over here we will simply put the value of dB, that is, we will get xk plus 1 whole square plus yk minus 1 whole square minus r square. That is, we can write the decision parameter as dk also. So this is dk. Now dk will come out to be equal to 2 into xk plus 1 whole square plus yk minus 1 whole square plus yk square minus 2r square. That is, now we have found out dk. Now we will find out dk plus 1. So this is no different than dk. The only difference is that we will simply write k as k plus 1 in the subscript, and the rest of it will be remain the same. That is, we over here also we will write yk plus 1 minus 1 whole square plus yk plus 1 square minus 2r square. So now we will do dk plus 1 minus dk. That is, on doing that we will write 2 into xk plus 1. I will be doing the whole solving part also, so that it is easy for you to understand. And we will here get 2k plus 1, sorry, 2 into xk plus 1 whole square and plus of yk plus 1 minus 1 whole square minus yk minus 1 whole square plus yk plus 1 whole square minus yk square minus 2r square plus 2r square. So these two will get cancelled. I have done nothing. I have just simply subtracted this equation and this equation. That is, we have subtracted dk plus 1 minus dk, and on doing so you will get this, that is this equation. So now on further solving this, you will get the equation as now over here we will put the value of xk plus 1 as xk plus 1. That is, this is in the subscript, and this is in we are simply adding 1 to xk. Now you must be wondering that why did we do that. Now here you will notice that coordinates of both the points, that is a and b, are xk plus 1 comma yk and xk plus 1 comma y minus k, yk minus 1. Now over here you will notice that the x coordinate is same. So if we are moving forward, irrespective that whether we choose a or whether we choose b, the x coordinate will remain the same. So that is why we are beforehand only initializing the value of xk plus 1 as xk plus 1. So on doing that, you will get the value of dk plus 1 minus dk equal to 2 into xk plus 2 whole square minus 2 into xk plus 1 whole square plus yk plus 1 minus 1 whole square minus of yk minus 1 whole square and plus yk plus 1 whole square minus yk square. Now we will further simplify it. That is, on simplification, you will get the value of dk plus 1 as dk plus 4 xk plus 2 into yk plus 1 whole square minus yk square minus 2 into yk plus 1 minus yk, and over here we will have 6. So I'm solving each of these steps and showing it to you so that it is easy for you to do it, and you can simply copy down it first and then practice on your own, and so that you don't have any confusion that where you are going wrong. So now we have found out the value of dk plus 1, and we will now consider two cases. That is, the first case is that when the value of dk, that is this part, is less than 0, or we can say the decision parameter. That is, let me show it to you again. We had considered the decision parameter as dk. So now we will find out the what will happen when we have the value of dk less than 0. That is, the point A is chosen. Always remember that whenever we have dk less than 1, then point A will be chosen, and we will get the coordinate of y as yk. That is, the y coordinate will remain the same. So on doing that, you will get the value of dk plus 1 as dk plus 4xk plus 6. We have done nothing. We have just put yk plus 1 is equal to yk in this equation. That is over here. And on doing that, you have got the values of dk plus 1 as dk plus 4xk plus 6. And the value of xk plus 1 will be xk plus 1, which is the same in every case. And over here, you will get the value of yk plus 1 as yk, as we have already used over here. So these are the three things that you have to remember whenever dk is less than 0. So now let us come to the second case, that is when the value of dk will be greater than equal to 0. That is, point B will be chosen. And over here the value of yk plus 1 will be taken as yk minus 1. Initially we had taken the value of yk as yk itself. Now we will be taking the value of yk plus 1 as yk minus 1. That is, the next coordinate of y will be now decremented by 1. So on doing so, you will get the value of dk plus 1 as dk plus 4xk minus 4yk plus 10. That is, we have done nothing. We have simply used this value, that is the value of yk as yk minus 1, and we have put this value in this equation. That is the equation over here, as we had done for the previous example, for the previous case. So now in proceeding, we will get that xk plus 1 will be equal to xk plus 1. As we had discussed earlier, xk plus 1 will be always be incremented, and yk plus 1 now will be given as yk minus 1. Earlier we had just only got yk, but now we are getting yk minus 1. So these are the three formulas over here you have to remember when the value of dk is greater than equal to 0, and these are the three formulas that you have to remember when the value of dk is less than 0. And you have to do nothing. Whenever dk is less than 0, take yk plus 1 as yk and put it in this equation, and whenever you get dk greater than 0, take this value of yk plus 1 and put it in this equation also. Then you will get the different formulas for this. Now we have found out the parameters, that is dk plus 1 for both the cases. Now we will find out the initial decision parameter. That is d naught. Now in order to find d naught, we will first of all write the value of dk, which we had earlier got. That is, value of dk was equal to 2 into xk plus 1 whole square plus yk square, yk minus 1 whole square plus yk square minus 2r square. So now we are finding the value of d naught, so we will write d naught as, which will be replaced by xk as x naught and yk by y naught. So on doing so, you will get 2 into x naught plus 1 whole square plus y naught square plus y naught minus 1 whole square and minus 2r square. So this is what you will get. So now initially we know that the starting, whenever we will start finding out the Bresenham circle drawing algorithm, we will start from this point, that is over here, and this coordinate is always given as 0 comma r. So we will be writing x naught as 0 and we will be writing y naught as r. We are doing this because we have to find out the initial decision parameter. First of all, we had just found out the decision parameter, which was a general decision parameter. Now we are going to be finding out the initial decision parameter. That is why we are taking out the initial coordinates. Always remember that whenever you are finding initial decision parameter, take the initial starting coordinates. So the initial starting coordinates will always be 0 comma r. So now we will be replacing x naught and y naught by 0 and r. And when doing so, you will get the value of d naught as 3 minus 2r. That is, you can simply put these two values of x naught and y naught in this equation, and you will get the value as 3 minus 2r. So guys, this is the derivation for Bresenham's circle drawing algorithm, and I hope that you were able to understand it. I know it is a little lengthy derivation because I've solved each and every part to show you that how we are solving the equations. So let me just summarize it up. First of all, we've made a octant, that is, it is an octant in which we plotted 2 points, that is A and B, and we wrote the coordinates for A and B. Then we found out the value of dA and dB, which were given in the diagram, and then we will find out the value of del A and del B. Then we will be doing squaring. From there we will get del A dash, which will be given by dA square minus r square, and similarly we will get dB dash. Now the decision parameter, remember this is not the initial decision parameter, but this is the decision parameter. So this will be given by dA dash plus dB dash. And on doing so, we will simply put the values of dA dash and del A dash and del B dash. We will simply put the values of del A dash and del B dash in this equation. And on further solving, we will get dk. That is this point, this part. Then we will simply put k as k plus 1 and we will get dk plus 1. And then we will subtract dk plus 1 by dk. And we will put the value of xk plus 1 as xk plus 1, because we know that whether we choose point A or whether we choose point B, the value of x will always be incremented. So on putting xk plus 1 as xk plus 1, we will get this equation. That is, this is the most important equation that you will get. Now we will consider the two cases. That is the first case when dk is less than 0, and we will take yk plus 1 as yk, and we will substitute this. We will be substituting this in this equation. Now similarly, we will take up the second case in which we will take dk greater than 0, in which we will substitute yk plus 1 as yk minus 1, and we will substitute this value over here. Over here I mean by this equation, and then we will get these three formulas. And now the most important part is when we have to find out the decision parameters. That is, the initial decision parameter has to be found out first by writing the value of dk. Then we will simply substitute xk as x naught and yk as y naught. On doing so, you will get the value of this equation, and now we will substitute the value of x naught and y naught as 0 comma r. On doing so, you will get the final initial decision parameter. So this is a derivation from Bresenham circle drawing algorithm. And guys, if you were able to understand it, just write wow in the comment section, and it would be great to know that you were able to understand the derivation and all the concepts related to it. And guys, this is a very important derivation because it is asked in the exam many times and it holds a good amount of marks. So guys, this is it for this video. See you in the next one.